Hello everyone. Welcome to Hydropower. Today we will be talking about the reservoir and their regulations, as well as need for flow regulations. So in the beginning we will talk about the 1. Introduction, 2. Examples, and 3. Key principles of reservoir and their regulations, and then we will talk about the need for flow regulations. So first let's start with the introduction of reservoir regulations. Reservoirs play a crucial role in water resource management, providing water supply, hydropower generation, flood control, and other benefits. Their regulations vary depending on factors such as the specific purpose of the reservoir, regional water needs, environmental considerations, and legal frameworks. Here are a few examples of reservoirs and their associated regulations. Let's clarify it with some examples. Regulations. Three Gorges Dam, China. Purpose: hydropower generation, flood control, navigation. Regulations. The operation of the Three Gorges Dam involves careful management of water levels to balance electricity generation with flood control. During the flood season, the reservoir is kept at a lower level to accommodate potential floodwaters, and releases are adjusted to mitigate downstream flooding. Hoover Dam, USA. Purpose: hydropower generation, water supply, irrigation. Regulations. The operation of the Hoover Dam involves maintaining water levels in Lake Mead to meet water supply and hydropower generation needs. Water releases are managed to ensure downstream water supply for agricultural and municipal use, as well as to generate electricity during peak demand. Now let's talk about the key principles. Reservoir regulations. Operating a versatile reservoir for irrigation, hydropower, and flood control involves adhering to these key reservoir regulation principles. Optimized water levels. The reservoir's water level fluctuates between normal and minimum pool levels, conserving water for irrigation needs within these bounds. Power generation stability. Maintaining water levels above the minimum threshold ensures consistent power generation. The spillway initiates controlled discharge if water levels exceed the normal pool. Flood capacity strategy. The reservoir's capacity strategy considers flood management. Moderate floods fit below the normal level, while more severe floods are accommodated between normal and maximum. Seasonal levels. Adaptation. During dry periods, water depletion for irrigation and power lowers reservoir levels. Pre-monsoon. Deliberate filling creates space to manage both water conservation and flood control in the rainy monsoon focus, with reduced irrigation demand during the monsoon, the rainy season. Water releases prioritize hydropower. The reservoir's level gradually rises, aiming to reach normal levels by the monsoon's end. Now, let's start with the introduction of need for flow regulations, particularly in the context of water management and hydropower, are essential for a variety of reasons. These regulations help ensure the sustainable use of water resources, mitigate environmental impacts, support various sectors of the economy, and address societal needs. Flow regulations are crucial in hydropower projects to ensure efficient and sustainable operation while minimizing negative impacts on the environment, downstream communities, and various water uses. Careful management of water flows helps optimize the benefits of hydropower while minimizing its potential negative impacts. Here are some key reasons for implementing flow regulations in hydropower projects. Energy optimization. Flow regulations align water releases with electricity demand, grid needs, and market conditions, optimizing hydropower generation for economic efficiency and grid stability. Reservoir stability. Flow rules maintain reservoir levels to prevent overfilling or excessive drawdown, safeguarding storage capacity, sediment control, and long-term project viability. Ecosystem preservation. Mimicking natural flow patterns through regulation supports downstream ecosystems, aiding habitat preservation, fish migration, and water quality protection. Fish passage. Flow management includes fish-friendly designs, enhancing fish migration pathways and sustaining aquatic biodiversity around the hydropower plant. Downstream needs. Regulations ensure sufficient water downstream for agriculture, municipal use, and navigation, preventing water scarcity and potential conflicts. Flood control. Managed water releases during heavy rainfall minimize flood risks by avoiding abrupt downstream water level changes. Sediment control. Flow rules consider sediment movement, preventing excessive buildup in the reservoir that could impact storage, infrastructure, and downstream environments. Drought resilience. Controlled water releases during droughts support downstream requirements, maintain water quality, and prevent ecological degradation. Safety assurance. Proper flow management ensures gradual water level changes, enhancing public safety and safeguarding communities, infrastructure, and recreation. Stakeholder collaboration. Engaging local communities, indigenous groups, and regulatory bodies in flow regulation decisions fosters inclusivity and addresses potential conflicts. Regulatory compliance. Flow regulations adhere to legal requirements, protecting the environment and downstream users as mandated by regulations. Sustainability focus. Flow regulations consider ecological, social, and economic aspects, promoting the long-term sustainability of the project and its surroundings. Thank you. See you in next video.